Well, folks, I've got about 10 minutes, so I thought we'd start this. It's a set I bought just over a year ago from Newark Radio Rally. I think it was £18 and not £14. And I'll just note down the date. DNT M40, and it's a supertuned version. These all went to, was it Cleartone? Or was it Radio Technic? Somebody called Radio Technic. Anyway, they all went and got bolt modified and allegedly work well. The trouble is you can't always sort these out. Anyway, you need 2 signal generators. And I've just had this a year and just not had time to get on with it. So I wanted to get on with it, see whether there's anything we can do. Now, I bought it from a radio rally. There's a danger sign there. And the danger sign is that it may well have been converted to 28 megs ham. And you can look like these wonderful drawings if you have one of these sets. As I was walking away with it, somebody says, "Oh, they're giving 40 quid for that." Well, chances are this is going to be very broken. And guess what? I wasn't there early and he didn't spot it and I did. I don't think I've even seen the side screws before. So I've got to determine, is that seal broken? I'll put the soldering iron on ready. You know what? Possibly not. The biggest snag with these, if they haven't been messed with, is dry joints between the 2 sides of the board. And these were playing up out of the box. Just going to cut this lead and we'll just bare a bit of wire afresh. There's no mic with this. I'll probably have to make one up. We've got an unlabelled mic up on the mic shelf, which has got a 5-pin DIN on the end, and you never know, it could be for DNT M40. You often see these on eBay, and it will say RCH M40, and of course it's really DNT. So these were a lot more money because they'd been reworked, and I mean that a lot more money, like over £100, that kind of region. But they do work well if they work. Whereas the M40 without the rework was very much a bleedover box. And I have bought some of those. So connect it up to power. It's my own set, so I don't have to be as cautious as when I do it for a customer. Connect up the test equipment. And I'll plug in the test equipment speaker later. Right, so I'm going to go straight for 13.8 volts and see what happens. Okay, nothing. Have we got a duff fuse? Well, the first thing is there isn't a fuse at all. So that would be a good reason for it not to work. Make sure the set's off. Ah, wow. See, the fuse holder's broken. So that's the problem there. We can have to put a new fuse holder on that. So we'll bypass that, bearing in mind we're running a power supply which is current limited, even though I've set it to 1.2 amps at this stage. Right, so it's powered up and it's doing 190 milliamps. It's starting to drop. And that is a jolly good sign. I always liked this channel 3 light. I'd not seen it on anything, and then the Murphy came along. We'll have that to DX, so it'll be as deaf as a post. And we'll find. I'll just go to the microphone shelf. Here it is. This is the unlabelled mic. It's one I've made up and then not labelled. Well, it isn't for this either. So it's still an unknown. So the first thing I'm going to have to do is make up a mic. Okay, so 90 minutes later I've done a plug. So it's number 11 on this chart, which is readily downloadable, which is, of course, is DNT M40. I think it's the only set that uses that pin out. I think the LCL, which is very similar chassis, it's a different pin out. And that might be what my other mic's for. Anyway, I'll get this one labelled. Alright, if you think the printer's making printing noise, it's printing out a copy of the instruction book. There's a good laugh in that. Well, the good news is this is actually going into transmit now. So let's put picture in picture on. But there's no oh, I've got unplugged into the aerial instead of the test gear. I can hear it transmitting over the... we've got a scanner on channel 19. And then we've got the tannoy system on channel 31. The scanner's only going to pick up within a couple of 100 yards. It picked me up doing that. Well, I'll go to the foot of our stairs. We may have got the new old stock set which hasn't been messed with. Still going to have to be serviced though. Perhaps it was worth more than 18 quid. 3.5 watts. Channel 40. Miles of frequency. 3.2 watts. Channel 1. 3.4 watts. Low power, is it on the front? Yep. Go to channel 20. And on low power we're doing 1, 2, 200, 3. I'm going to give it 300 milliwatts. And back to normal power, and it's drawing 1.03 amps. Deviation. Wow, we're going to take that with a pinch of salt because I need to check that with the test set behind. VCO is either locked or not locked. You can monitor the lock pin if you look at the data book for the phase lock loop chip. But the fact it's locked on all 40 channels is all we need to do. Now frequency seems to leave something to be desired. You've got to set them 3 times. You've got to set the 10.24 reference oscillator, you've got to set the transmit, and then you've got to set the receive with a second signal generator separately. So let's see what it's doing on transmit. So it's okay. That's in spec, a bit low but in spec. Now then, receive, it should be really good. What I'm going to try and do, I bought a couple of these sets recently. There's some, to somebody like myself who doesn't do mobile phones and doesn't do Facebook and all that kind of thing. I'll tell you why I don't do Facebook. I did a wonderful thing on HMV radio, Stereo Master radiograms, with details and photographs of every model ever produced. And then some young lady decided she was going to advertise her GEC radiogram, which had nothing to do whatsoever apart from the word radiogram. It's like doing a web page about Lamborghini, and then somebody suddenly wants to put their Porsche on there. It's nothing to do with it. Anyway, I asked her kindly to remove the advert, and she says I was a grumpy old man, so I just closed my entire Facebook account. Fed up of looking at people's dinners anyway. Anyway, Mr. Chippy found that somebody selling a couple of them £10 each off Facebook Marketplace, which is not something I'd like to buy from. He bought a guitar amplifier. This bloke comes out between two council houses, clearly not living at either of them. You know, where does he live? Has it just nicked? You just don't know. And this, in this instance, I went over to Derby and we picked them up. It was a right rainy day as well, £10 each, and I'll do one of those next week. But you know, if things go wrong, there doesn't seem to be any teeth like there are with eBay. Right, so we'll dial this in. Let's look at where we are. I didn't show you the signal generator, the frequency anyway. You'll have to take my word for it. It was 087, and we'll put in 2779125 on the signal generator. I can actually hear it, even though we're at very quiet volume. I want that spot on because we've got to set the frequency with it. And it's 0.3 of a microvolt we're actually hearing. Now I'm going to plug the test equipment speaker in, and then we'll be able to get synad readings. It doesn't sound nice, so you know it's certainly going to want sorting out. But what we've got there is 0.84 microvolts, and then for 10 dB, we've got 0.71. For 20. Ooh, if it can do it, I'd say 10 microvolts. This is all noise, it's not so much important. Squelch threshold. I can't remember whether these are good or bad. It's a long time since I've seen one. So I've put the squelch to full. It's coming in at 3. Let's get an exact reading. It's actually coming in at 2 microvolts. It's nearly as lousy as yesterday's clone Amstrad. I put it in the wrong box anyway. Now we'll get the sensitivity. Switch this thing to threshold. At least it shuts down. 0.7 of a microvolt is excellent. So, let's put 100 microvolts on the test set for an S9 signal, and it's for S9 it is in fact 23 microvolts, so it's a bit generous. So what does the meter read on transmit? Nearly the centre of the red zone. So I'll just put red plus, it's supposed to be the centre of the red zone. So we want to try and get that to the thing. Meter lamp works. Switches work so far. Let's just check the DX local thing. Yeah. Absolutely fine. And it's replace fuse holder X Newark Rally 2022. I'm convinced it was 18, but Mark will probably tell me what it was. So there we go. It would have been nice to have it complete with the instruction book and the mic. Now what we're going to do is pause the video, and I'm just going to clip together the instruction book, and we'll just go through that spec I've just drawn up to what it says in the book. Right, let's just pop that off. 11 to 16 volts. So 13.2 nominal, so we're absolutely fine at 13.8, as you would expect. And let's have a look at what the receiver is supposed to do. Well, it's supposed to do better than 0.4 for 10 dB synad. That's what it says in black and white. So what did we have? We've got 0.7, so it's not there. Selectivity we can't test at present. I'm going to rig something up, but with the organ job on still underway, I just haven't got the time. I have to put 4 hours a day into that. Squelch is adjustable between 0.1 and 1.5 microvolts, so we've got between 0.7 and 1.5 microvolts, so that's not quite there. It wants to be much, much higher than that. I want to be 100 microvolts. Probably won't do it. And that's what you expect it to be. Well, it goes on with some service information, which is really useful. Got a circuit, I've got a layout, need a microscope to look at it. What else have we got? Oh, this is lovely, isn't it? We wish to thank you for selecting this product and welcome you to the growing family of satisfied CB users around Europe. We feel certain you will get maximum enjoyment from this new addition to your home or car. Please read these operating instructions very carefully and be sure to keep them handy for convenient reference. You've purchased a first-class article which, used correctly, will provide you with endless pleasure. Radio where and when you wish to use it. You are in communication with the world at the touch of a switch. Isn't that wonderful? Your CB friends are enthusiastic and have pleasure in each conversation. Whether you wish to be highly technical or just wish to have a chat at any time, it's always possible. Remember, your partners in CB are friendly, helpful people, in particular during times of distress. We know that you'll be helpful to others too. Therefore, join in the great circle of CB enthusiastic. That isn't a good translation. Be assured, your radio is made by one of the leading manufacturers in the world with the greatest knowledge in this sphere. The Citizens Band lies between the shortwave broadcast and the 10-metre amateur radio bands. Was established in the UK during the autumn of 1981. Acquiring a license requires no technical knowledge. Well, let's hope we can pick some of the swearers and bucket mouths on 19 on their burners from Nottingham when we've finished this. Rose-coloured spectacles or what? Time to take the screws out. Now, if I remember rightly, no screwdriver I have fits. So are these smaller? I think they're M2.5 instead of M3. And my problem is I don't seem to have to get them in black. I know we've drilled these out and retapped for M3 in the past. Because usually the lids have been off 100 times. Am I going to break the seal? It says don't. Let's pop it off that way. Oh yes, it's still sealed. Oh, it's not now. Yes, we've got the crystal filter. So somebody paid a pretty penny for this and didn't use it. I always thought these relays were old-fashioned even at this time, but they're still doing new sets with relays in. It's the remote on the floor. Right, well, we'll find the remote off the floor. So the first thing we need to do is to set 10.24 on this reference oscillator. And we are not going anywhere. If that's wrong, the transmit's wrong, the receive's wrong, and the IF's wrong. And it sounds like the IF's wrong because it does sound awful. So I'll have to remind myself where to connect something to. Pin 3 or pin 4 of the phase lock loop chip. We'll use the little oscilloscope for convenience. It would be even more handy if we actually had a probe which wasn't bits of wire. I think they've been soldered to here as well because there's remnants of solder. Switch back on. So 10.2389. So we're going to adjust the 10.24 for 10.24, if it will go. And it won't. So it's 10.2393, which is at least better than it where it was. So that's all we can do. So we'll switch that off, disconnect. It's going to make the IF slightly lopsided, but not as lopsided as it was. And we'll just pop the lid back on. We'll switch this off and put it away. Okay, so we'll go over to the frequency counter, switch the radio back on, and set up. Now you can see we've got a totally different frequency showing, much higher than we had before. So now we need to adjust the transmit one. And I can't remember which one it was, so we'll just, what can we do? Can we touch that and just see if it makes a difference? Made a difference there. It's hard to tell. Anyway, I've gone right. So I want 79125. So let's hope it goes down low enough. It does. So we'll set that only very slightly high. And now we'll set the receive, so we'll get them all done with in one fell swoop. So I'm going to switch the test set to the signal generator and make sure that's 2779125, absolutely spot on. Okay, so that's pretty spot on. So that's with the tone. That was with the tone. But it's now miles off frequency because I've altered the 10.24. So, with the second signal generator, which I will have to go and plug in, there we go. I've finally got it. So you can hear that musical note. You're either side of it. So that's now spot on frequency. Good. We'll put that on one side. And now the detector's miles out. I'll just remind myself as to where I think the detector is. L4. Of course, it's not labelled, is it? That's L4. So let's put the oscilloscope on. And that's dreadful. And that tool's not going to fit that radio. Just do some quick adjustments to kind of get that somewhere near. Well, it doesn't want to be somewhere near, so what we're going to do, we'll carry on with transmit. So picture's on, wrong meter. I'll just see where the lower stages are of this. L17 down. 17, 16, 15. I'm not going to touch those two because the set's not far out, so there's no point in disturbing them. So the first core I come to, I thought was broken but isn't. It's dancing around on its rubber band. I can't actually feel one in there, but there is L8 in there. Anyway, we'll turn this one down to for 4 watts. And 4 watts is nicely there. So let's look at the other channels. .1 watts. 3.8 watts. So I think we need to do a bit of a bring that up to there, and we'll drop that no, I can't get a tool to go into there. I'm not going to unsolder it. Oh, I've got one in. So we'll just see whether we can get something a bit closer. We've got 4 watts there. 4 watts there. I've got 3.9 watts there. And on the, let's go back to channel 20, low power is now 500 milliwatts. So we need to bring that down. I don't have Busby round, do I? Want doing 100 milliwatts more than I'm allowed. Those abroad, Busby was a cartoon bird character, and British Telecom, who'd taken over from the General Post Office, were advertising about their wonderful telephone call prices. Well, in those days, the people who policed the airwaves were part of the General Post Office. And so if people got smitten by the inspectors and the gear confiscated and caught back in the illegal days, or even nowadays with illegal operation, then Busby'd got you. Well, British Telecom had to drop Busby because I think the introduction of CB radio just ruined the whole concept of this cuddly cartoon bird. Busby will get you. So we need to find low power. I'm looking at that like a Wally. Low power. One thing I do know is resistor 98 is the meter. It's 136 for low power. So 98 is the TX meter, which is there. Let's pop it back onto high power and set for that for the center of the red zone, so that's now there. And then whatever I just said, was it 36 or something? 136 is low power. $400 milliwatts. So that's that done. A deviation we'll do with the test set behind me. I need to just know what I'm doing, which one it is. Well, a bit of deduction here, isn't it? If that's transmit and that's receive meter, then there's only deviation, and if it's got squelch left to adjust, isn't there? I can't see a squelch preset. That's why they've got lousy squelch, isn't it? Is the one on the circuit? No. So that's deviation. So I'm just going to unplug from this test set. We'll plug into the other one, and then we've completed what we want to do on transmit. And I'll move on to my next task and come back to this later. So we thought it was 1.5 on the other test set. It is, it's 1.5. Oh well. No, it's not, it's 2.2. Let's see if this is lying or not lying now. Well, it's lying now. It says it's 1.5 and it's now 2.2. Oh well, that's another thing done. So it's now 2.2 to 2.5 kilohertz, low power 400 milliwatts, current consumption in full power is 1.16, and we know it's on frequency 27.79125. So we're going to have to sort out the receive. So it's on frequency, but the IF sounds out. So we'll come back to this in a bit. Right, we'll come back to this radio. Let's just see how if we can just tune this IF and all that better for the receive and draw it to a close. What we're going to look at, oscilloscope. So we've got that distortion. Let's just see whether we can iron it out. Well, I wonder if that's a false peak that I've got it on. That's definitely the peak. But it's not nice. So take it just a fraction away from peak. It's difficult to guess this until you know what it's going to sound like. That's clearly not the nicest IF in the world, is it? No, Mr. Tango, it isn't. Let's just see what we've got now. Let's just deal with the front end. Oh, I'll switch to the cyanide meter. I don't really think we need to adjust this, but just for the laugh we will. I think that was spot on where they'd got it. I think that's the best we're going to achieve. So we'll look at S9 and adjust the meter accordingly. Oh, whoa, 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 I haven't got the attenuator zeroed. There we go. Look at the switch to local, you'll see it drops. Let's see what sensitivity we've got now. Well, it's actually worse. But it probably sounds right now. just have a final twiddle. If we twiddle with these, I can get them back again. Ah, now that can bring the sensitivity dramatically better. But it's sounding absolutely abysmal. Let's now go back to the oscilloscope, see what that's given us. Well, actually, that's not awful, is it? So let's get that to there. Go back to sensitivity. .92. I think I'd rather having it sounding decent with acceptable sensitivity, which is where we are now. Once again, I'll just go back to this. And go back to the oscilloscope. So we've hit peak and I've just gone backwards a bit to try and have that compromise. So I think with it sounding half decent, we'll run for this. So 0.95 microvolts, so we fixed it worse, but it's no longer distorted. 10, 0.75. And now our 20 dB is 4.6. So we have cut down the noise and distortion. The squelch is going to be abysmal. That's now correct. Abysmal squelch. Here we go. Set to full. .7. No, 1.5. 1.5. Far too sensitive. Threshold. .3. So everything's right. We'll put it together and we'll see if we can hear anybody to judge what it actually sounds like. So you can see it was quite a long way out of alignment. So 10.24, transmit, receive with a second signal generator at 10.695. And you're looking for that 0 beat. I'll be interested to compare this. As I say, we'll get one of the other ones out next week, which I bought via Mr. Chippy's Facebook thingy. I didn't break it. Now, if you come across the B40 base, which is the base station version of this with a built-in power supply, it's like a longer version with a power supply in the back. Now, that power supply is a 12-volt power supply, it's not 13.8. So all the component values in the radio are different. So don't think, oh, I've got a scrap chassis, one of these, I can fix one of those. Every component is different because it's for that 12-volt power supply. And they'll still do a full 4 watts, but on 12 volts this time. So it's just one to watch, and they are crystal filtered as factory standard, whereas the normal version of this, the non-supertuned version, isn't. I'm not bothered about bleedover anyway, because we're not going to get it, but people who are in towns, it's still going to be a problem. But of course, a lot of the problems generated by the people who are operating illegally with ridiculously high deviation and illegal power and so on. So it's not always the set's fault. So nothing changes there. I'd actually need to go out and buy a special screwdriver for these, you know, because nothing I've got fits them properly. Or do what I did before and drill them out and re-drill them for... it was that rubbish one, wasn't it, in this position? Drill them for M4. Sorry, M3. That's that one, that's the one. I kept it on one side. We'll have to put it back because all I can do is put a silver one in. We'll put that in as best we can. I don't need to go super tight on these anyway. But it's nice to see one in nice condition. So it got the reputation, did I say that right? Reputation, that DNT stood for does need tuning. So I hope Mr. Bloke at the radio rally who said, oh, I'd have given 40 quid for that, I hope he watches this video. And then find out whether he's got 2 signal generators to put it right. So we'll unplug, we are unplugged from the test speaker. You know what, the meter's failed, hasn't it? Would you believe that? So, I'll put it on the aerial. I can fix the meter bulb without putting it on the test gear. Just see whether we can hear anybody. Trouble is, some of the people out there are operating off frequency anyway. One Anna, Roger. Alright, pause the video and dismantle it again and do the meter lamp. Okay, well I've done the meter lamp and we've just spoken to Mr. Chippy in the next room. Well, Nana Roger, we're not going to get one of those. So we'll do it on the air test and we'll see what it sounds like and how it works around Scratchy Corner. So thanks for watching the DNT M40 supertuned version from 1982.